All right, well, those of us in the room and those watching, thank you for coming. This is the November meeting of the Oklahoma City Java User Group, and tonight we have Matt Hicks talking about LightDB and Scala. Hi, Matt. And we want to thank our sponsor, Techlahoma, for the meeting space and the food. And I don't really have much else to say, so we'll just hand it over to Matt and let him take it away. Thank you, sir.
So tonight we're going to talk about LightDB, which is a database that I created. I mean, we can call it a database. It's actually a database built on top of other databases. So, I mean, plenty of databases do that, so I'm calling it a database. But it's built in Scala, and this is somebody's trying to get in, I think. Or they're just banging on the door.
I did hear something.
Okay, so written in Scala. Hello.
We just started.
This is about the journey that I took in order to decide to do something so insane as to create a database. And my pretty image here. So this is me. This is my in-depth bio here.
Which one is you?
So my wife didn't believe that anybody would get this reference. I'm hoping somebody does.
Oh yeah. Not me.
No.
Troopers.
No? Starship Troopers. Best B movie of all time.
Okay, yep.
Would you like to know more? All right, that's enough looking at me. Now, why? So I was building a platform for entity deduplication. So the fuzzy matching of names and addresses and phone numbers and email addresses and all that mess to try to say is person A the same as person B. And it's a fuzzy, nasty, complex problem. And I have millions and millions of records that I have to do this for. And I tried using existing database options, which took days and days to process initially. And I thought, surely there's a better way to do this, because I tried lots of things. But this is the first part, is sort of discussing how I went about this and why I came up with building what I did. And coming from days to process to hours. So I'm not going to read all the slides. You can read this if you want. This is more just additional insights. But the idea about being able to do higher level processing on the data sets than you can. I mean, imagine trying to write a stored procedure that analyzes records and does fuzzy matching along with additional logic tests to do all sorts of stuff. It can be done, but it's nasty, messy, and painful. And so I tried Postgres and the stored procedure, and it was just messy, and it felt so wrong. And so ultimately, I tried a few things with some embedded databases and found that, wow, performance is incredible for embedded databases versus server databases. So the different types of databases that exist, for anybody that's not as much aware, the standard that most people see are relational databases: MySQL, Postgres, MariaDB, Oracle, Microsoft SQL, all those good ones. Those are pretty common and pretty useful, but they manage relationships between the tables, and the schemas deployed in the database and managed there. Key value stores, pretty simple, which I heavily utilize actually, and are actually the basis for a lot of like graph databases. Heavily utilize key value stores, just because of the performance of being able to cross-link between records very quickly. Document databases like MongoDB are also things I tried. I tried graph databases like Neo4j, which very, very quickly crashed. Neo4j is not meant for scale at all. If you ever mess with Neo4j, realize that keep your data set small or don't use it. ArangoDB I used, and I love ArangoDB before I started down my LightDB path. ArangoDB was my preferred choice because it's a very powerful database, It's a multi-model database. You can use it as a document database, key value store, or a graph database. And it has a different language called AQL, Arango Query Language. And it is more like writing stored procedures or like PL/SQL, but in a more structured way. So you can actually create like variables and define loops and things like that, more advanced logic in your code. But again, the problem with that is you're feeding all this stuff to the server and you have a limited language that's able to process this stuff. And I kept coming back to, man, if I could just represent this in my language, Scala, then this would be so much easier. And then embedded databases, most of you probably used some at some point, like Derby, H2, SQLite, things like that. So, have any of you used a graph database before? No. No. Does anybody know what a graph database
Like
is?
Neo4j?
Like Neo4j,
Oh,
yeah.
yeah. We had last Jug was about.
Yeah, Jennifer
Oh,
Rice
yeah.
came out. Yeah.
Nice.
Yep.
Okay. Well, I do not mean to disparage it if she watches this video.
I'm gonna let her know.
That's fine.
Yeah.
I mean, Neo4j has some really cool features, but it is not meant to scale.
We use it right now. Ours is very scalable.
How many records do you have in
I
it?
don't know. I don't work with it. But we're using it very, okay, I'll tell you this. It's a Fortune 500 logistics company,
Uh-huh.
and all the events coming from the trucks are going to Neo4j, and everybody's consuming them.
So more than, say, 10 million?
Oh yeah.
Wow.
It's very,
Interesting.
it's the foundation of our tracking.
Sounds like you need to give a talk because I wouldn't think Neo4j for event tracking or event sourcing.
Yeah, I wouldn't either. Although, I mean, if you're doing graph,
Maybe in a January talk, you talk to us about how
I
you use
don't know if I can.
so for anybody that's not familiar with a graph database, one of the primary benefits to a graph database is traversals. So a common example scenario is this: if you're trying to plan a flight from one place to another place, trying to find the shortest route. So if you have to make connections between the point A and point B, finding the shortest route to that destination and determining those. Because if you have hundreds of thousands of different airports and you're trying to find what are my options to get from A to B, try doing that in a SQL database and you'll start tearing your hair out because it's painful and slow. Postgres has traversal capabilities, but it's less efficient. Mongo has traversal capabilities, also less efficient, but where you're talking seconds to process a lot of those types of things, a graph database is designed to process it in milliseconds.
Just from personal experience, because we researched SQL Server released graph feature.
Oh, did they?
But the problem is that it's still built on the old indices approach, so it's much better in graph traversal, but it's not as good as Neo4j.
Right.
But the cost, the biggest drawback with Neo4j is the cost.
Sure, yeah. Well, and they're kind of ruthless about that because they want to know your company. How big is your company? How many employees do you have? How much money do you guys make? Now we'll give you a price of how much it's going to cost. Okay, so what I thought, I was coining a term whenever I started this process of a computational database, but apparently that's actually a used term and it's actually similar to what I came up with. So that's great, but that's what I created is what I call a computational database where there's a lot of work that has to be done while I'm processing data. And you can think of Spark, Apache Spark as sort of the same concept, but instead of just processing a stream, it's processing in the database. And I mean, obviously you can still do that with Spark, but this is meant to be embedded database level. So one of the really cool things about this, to me, that I believe takes you well beyond graph traversals, is graph traversal is extremely limited in how you can process through. You have to have left to right kind of connections, and you can parse those down with some flexibility, but you're still very limited in how you can do that. Whereas in this, because the logic of the code is in the language itself, at each step I can decide how, if I want to traverse in a normal graph style, I can do so, but I can also decide to rewind or go up another path or branch in any way I so desire. So I'm not linearly tied like a graph traversal is.
Thank you, Chad.
I'm able to go any direction in any way I want. And that's where I think a lot of the power of this system comes into play for me. So, why Scala? Everybody knows that I'm a huge lover
Well,
of Scala.
this is your chance.
Sell us.
Honestly, I'm a big fan of Kotlin these days too. I think it's a good language, and there's a lot of value to it. Java's come a long way in the past several years. They keep on making themselves more like Scala, which is interesting. But it's less pretty.
Embrace and extend.
Hold on. Are you saying Scala is pretty?
Yes, Scala can be pretty, and I can show you some code that'll make you drool.
Well,
I'll
take your word for
That sounds like a challenge.
Yeah.
Okay.
You know.
I'll just say my brother gave a presentation years ago that showed Scala code, and the challenge was, is this Scala code or is this dial-up modem line noise?
Well, so
Wow.
so
Okay.
I will say, this is what I always used to say is, with great power comes great responsibility. It's one of the most flexible languages. It's meant for DSLs. So the ability to, I mean, there are people have written basic interpreters that you can basically write basic code in it, and it is Scala code because it's got a DSL to support that. And it's an extremely powerful language. In fact, I had something years ago called Scala relational that allowed you to write SQL code directly in Scala, and then it would compile to, it would generate the SQL query script from that. But you're basically writing SQL, but in a type-safe language.
Like Link.
Do what?
Like,
Yeah. So, well, except for that's not directly SQL, is it? I mean, it's derivative.
It's embedded in the language. Though.
Right.
Yeah.
I mean, that's the same argument for Lisp. You can make anything out of it, right?
All right. We can go down that rabbit trail forever.
Sure.
Yeah.
We'll bust
All
your
right.
chops later. Proceed.
So, but I do say Kotlin has come a long way and has a lot of features. One of the cool things about Scala that I think surpasses most languages is the macros or meta capabilities of the language. So, like, for example, I have a JSON library that I wrote that at compile time, it introspects your classes and such and allows it to generate the code to map to that. And I have the fastest logging library in the JVM I wrote called Scribe, and it's in Scala, and it beats log4j by like 10,000 miles, but it's because it uses macros in order to do compile time validation and compile time generation of code to allow it to be faster than anything else. And that, I think, is where Scala really excels, in addition to the focus on immutability and conciseness. Now, all that said, Jason, to your point, it can be hideous if you do it wrong.
Well, I've seen ugly Java code too. So
Sure.
I'm just,
That's all Java
Yeah.
code.
Come on now.
But Kotlin is sort of, I would say, a more balanced approach. There are some meta capabilities, but it's more code generation, which I have mixed feelings about. You can do compile time plugin kind of stuff with it, but it's not as powerful as Scala. The type system's not as powerful. It's not as powerful as Scala is, but that can be a good thing sometimes because Scala is arguably sometimes too powerful. Okay, I've already gone into most of this, and just to be clear, I'm not going to spend a whole lot of time on this slide presentation. I want to get you guys into code, and the last time I was at the Jug, somebody said that they wanted to see Reactify, which is another library I wrote, so I thought I'd bust out some code here in a few minutes.
Code's always good.
So I won't go into this. So here's some benchmarks. This is the fun stuff. So I wrote a bunch of benchmarks. I'm only showing you a little bit, but this is a benchmark that has how many records? I don't remember how many. I think like 100 million records and how many seconds it takes multi-threadedly to request each record one by one.
It's a okay.
And it's a crazy scenario, but for my purposes, this was a use case I was trying to do it because I needed to actually process through and horizontally jump around to gather records of different types and based on the needs of each object I was processing. And so you can see Postgres is an awesome query language, and this is not a good demonstration of how awesome it is, but because I'm completely misusing it. But
these are round trip. There's multiple round trips.
this is
separate
like
transaction.
100 million round trips,
Yeah.
Gotcha.
which, you know,
In 2,500 is not
2,500 seconds is pretty good for it. But look
over the
at
network or local.
local,
Oh, wow,
I mean-
that's too bad.
yeah. But if you look at like H2 or SQLite, the map SQLite one, that's not a good example because that's actually in memory. So it's cheating, which I remove in the next slide. Because
But all these other than Postgres are in process.
yeah, all of the other ones are embedded.
Yeah, so that makes a big difference.
And poor Lucene over here going so slow.
Mm.
Yeah, this is why Lucene shouldn't just be used by itself because it's so powerful. But if you're just
It's not for
getting it
individual
done-
reads.
Yeah.
Yeah. This is a bunch of single reads.
So this is after removing Postgres, so you can see a little bit better at scale how these stack up.
You took Lucene. Oh no. Yeah, Lucene's out too.
So you can see some of these that I have. You've got LightDB with RocksDB and Lucene. So one of the features of LightDB is what I call a split store. So there's the storage mechanism and there's the search mechanism.
Okay.
And so whenever you are inserting records, it puts it into both. But if you search, it queries over here, but it only gets back the IDs, and then it grabs the object out of the database itself because the full object is stored in the database on the store side. And so it basically is able to leverage the power of both scenarios. So SQLite, you can see, is pretty fast, but SQLite coupled with HaloDB, which is a key value store, an embedded key value store in Java, which, man, it's been... I'm guessing nobody here has ever heard of HaloDB.
No, I'm using Redis.
Yeah, it's been abandoned,
Oh.
which is hilarious, but Yahoo created it, and it is so crazy fast. It beats down RocksDB, which is also insanely fast, and that's the basis what Facebook uses for their key value store. But this is using RocksDB and Lucene, and it's good and very powerful, but HaloDB is just a rock star for performance. It makes me so sad that Yahoo has sort of gone away.
Is it open source? You can support it.
Yeah, I do. I've been making some changes to it because somebody has to. And I'm primarily, it's the HaloDB Lucene coupling that I use in this major project that I'm building because all around it tends to outperform everything else.
All right.
So yeah, I am kind of supporting it, and I'm actually tempted to roll my own version of it into LightDB. Anyway, so Derby's interesting because have you ever heard of Derby?
Oh yeah.
Okay, it's an old school database. It was actually a friend of mine that's a big. He still does a lot of Java, but I was talking to him about these benchmarks, and he was like, "Have you tried Derby?"
Yeah.
I was like, "No," but I threw it in there just to make him happy more than anything. But there's places where it actually.
Was he happy?
Yeah, he was very happy. Well, this benchmark makes him very happy.
All right.
Well, there you go.
Because this is just streaming through. This is basically doing multiple concurrent streams of the entire database, and Derby does phenomenally well. I mean, surprisingly well for how old Derby is.
Yeah. Oracle's old too, by the way. So.
I did not expect Derby to beat H2 that much.
Yeah. I am surprised. However, I don't know if I threw this in here just to show why I don't use Derby. This is how long it takes to insert the records.
Oh no.
Is that 180 seconds?
Yeah, 180 seconds for just this small set.
Not minutes.
That's why it says, oh, you can't see it. My screen shows seconds elapsed on the left side, but
Yeah.
Oh.
Oh, okay.
it's clipped.
It shows on
Oh,
the
I see the
stream.
dot.
It's on the stream.
Yeah, that,
It's streamed though.
Yeah.
Okay.
It's some TV.
It's not shown on the TV, but it is
Yeah,
shown
yeah.
on the stream, so you're good.
so, I mean, you can see here SQLite does really well at inserting records, and H2 actually outperforms SQLite when it comes to concurrent performance. But it's really exciting to me because I've learned so much about all these various databases
Yeah.
just in the process of doing this. And with one line of code, I can switch between which database I use. So it's been a fun journey to sort of see how they compare and contrast. And it's also interesting because these benchmarks, as I'm sure you'll be shocked to hear, don't really stack up to real world scenarios all that well. So I plug it into my system and I'm like, now this SQLite should be by far the fastest. And no, it's not.
The real world is brutal.
I
on
know,
benchmarks.
it can be a real jerk. Horizontal scalability. This is my disclaimer of this is one of the big limitations of LightDB because I don't have horizontal scalability. Although part of the reason that I built it this way is so that on a single node, I can scale far, far beyond what you would normally have on a single machine. However, I do have plans to support horizontal scalability. I don't know. Do you guys know how Twitter is built for their horizontal scaling Lucene database? So they use Lucene internally, and so they have basically sharded Lucene instances, and so they have sort of a short-lived instance that ends up in the larger instance, and they have multiple shards that then populate back. And I'm actually thinking about doing something similar, but then building it on top of like RabbitMQ or something for cross communication, and then interposing the data back out. So the query would basically go to all the instances, and then it would basically
The one that
bring
has the
them
answer.
together. Well, not just the answer, but there's probably many answers coming from the various sources, and so it just basically has to put them back together in the right order. That's it. I'm
I
done.
thought we were going to see
I'll see you
code.
guys.
No.
You are. That's why
I was
this
about
is a
to get
short
emotional.
So I want to talk about your use case just for just a little
Sure.
bit, if you don't mind.
Sure.
So you're saying that you had to go through, I don't know who or what kind of demographics you had, right? Like they were customer records or just.
This is lots of data sets of information like courthouse records that have been parsed and put in that I'm extrapolating information from, respondent data, oil wells. So the primary purpose is these companies are paying me for is to build this platform so they can buy minerals and find people who own minerals. And I don't know if you've ever, if you own land, you've probably gotten letters in the mail about, hey, we want to buy your mineral rights, blah blah blah. And this is why this is such a big problem. Is they shotgun out to all these people. They have no idea how much you own. They just know that you happen to own in some vicinity around here, and they're trying to get people to respond to them in order to say, hey, now that we've sent you down and you called us back, let's find out what you actually own. But they're sending these letters out to people that sometimes own 1% of 1% of 1% of 1% of 5 acres.
Yeah.
And they don't want to buy your land. They want to buy the people that have much more, but they have no way of figuring that out, and that's what the system is built to do.
So I've seen people in the courthouse literally digitizing all the books. It's
Right.
crazy
And I
work.
have
I mean,
that
they
in my
literally
system.
scan all the paper pages from back when.
Yeah.
Brutal work.
Yeah. Well, I mean, one of the companies that I work with is Osberg. They're
Yeah.
Yep.
Yeah.
I
Also a
have their,
Scala shop.
Yep. Yeah. That's why they talk to me.
The only
But I
ones who
have
do.
their entire database in my platforms to be able to parse and handle, and so we utilize that heavily to enrich the data.
So you got mineral rights data in there, but you also have kind of, I don't want to say customer profiles, but you have customer data, first name, last name, maybe a town or something. So you've got different data sets, gives you different attributes about
Right.
that person, and so
And the complexity is taking all that fuzzy information and trying to say this belongs here and
Yeah.
this belongs here. These are the same
is
person.
this
These
Mark
aren't
Smith,
the
the
same
same Mark
people.
Smith that I'm talking about over here? So
And you got to traverse corporate ownership hierarchies too, right?
Yeah.
That's
It's a
more
mess.
fuzzy.
Legal descriptions, cause numbers, API numbers, all that stuff, and trying to bring it all together and into a rich graphical environment, which is built in Flutter, which I'll have to give another talk about Flutter because it's actually a really interesting system. But Yeah, it's a really powerful system, and it's going really well, surprisingly well.
Okay. Thank you.
Okay, so let's look at some code. Hey, this is my system. Actually, let's. All right. I'm going to create a new project. We're just going to create a little database real quick using LightDB. And you can see my process of creating a new Scala project, which is probably not the right way that people do it, but
If it worked, it's good enough.
That's what I do.
what do you use, Maven?
Oh yes.
If you could a little bit less
Yeah.
than full screen, we could see the left side.
Let me change
It's
that.
only for us in this room.
Yeah, the
Is there
stream
a-
is fine. It's
is
just
there
that
Let me
TV's
change
a
it
little,
to, well,
or just
Can I see your remote? Send
let
it
me
to
try
the-
this. Let me try this real better. Can you see? Yeah, that's
Yeah,
everything.
got it.
Okay, it's just 16 by 10, that's the problem.
mm.
All right, so LightDB example. I don't need a version. Scala version. I do need 13. I'm not using 3. Yeah, do you do this and can you do this in Maven?
No,
Oh no, not at all.
Exactly. Boom.
Copy and paste.
Well, I was Googling for 2 hours.
Working project, 3 lines of code.
I don't see it working yet.
Name of the project, the Scala version I'm using, and the dependency, bless you, to LightDB so I can use it. Now let's open it up and prove that it's a working project. Let's hope. You can see my confidence level is high.
All right.
It's still extracting. Give it a second. It may still break.
Maiden would have already loaded.
Boom, it broke. Cool. Oh, right, because I need a dependency.
Oh, you need to put a store.
No, it's that I don't have, there's a repo for,
Oh.
I need Jetpack.
This is how I use Maven, by the way. Look up a working example, copy, paste.
So what's Jetpack?
It's like a Maven repository.
But why do you need that instead of repo one?
Because HaloDB, the official HaloDB instance that I'm using, isn't there.
It's not in repo one?
No.
Sonatype?
No, which I'm probably going to be pushing my own instance of it.
Yeah.
I just don't.
Oh, it's that abandoned.
Yeah.
Wow. Okay.
Yeah, no, I was not joking, but it's abandoned.
Jetpack is like the old dustbin, is that?
Jetpack is awesome.
Why is it awesome?
If you like to live on the edge.
The edge is in repo one. I've seen it.
The last update was last year, and it's because somebody was kind enough to go in and merge some pull requests.
Somebody who's ex Yahoo.
Yeah.
Wow.
Patch 1, it was just a dependent bot or something.
Yeah.
Yeah.
A
Yeah,
nice,
somebody
a nice
was
person.
being very nice.
So-
All right, so what else?
There we go.
No, it's still breaking.
I know, but we got more. I like new errors.
Yes, that's progress.
Yes.
Expected 15, but was 5?
What?
That's how you know you're getting progress.
Oh, 15. You know, if you get one number in there, SBT doesn't like really old versions of Scala. There you go. Yay! All right, now we have a working project.
Now it works. Awesome.
Now source main Scala example, and now I have to reload SBT to get it to pick up the project directory. Okay, now we're going to create example. Now, def main, you know, like public static void main.
Mm-hmm.
This is the Scala equivalent.
I think in Python you can just start typing code.
Well, you can in Scala too. You can in Scala 3. I don't use Scala 3 because
Scala 3, you just have a cold open, just
Yeah, you can just create Scala
Mhm.
scripts and everything. Actually, you can in Scala too, but
yeah.
I prefer old
a
school.
little bit of structure.
All right, so we're gonna create a little database here. We'll call it object DB extends LightDB.
Okay.
That's easy enough. Now I implement the things. I'm gonna say some path dot DB. We'll just stick it there, and then I'll
So
create
it's file backed.
do what?
It'll be file backed.
Yeah.
Yeah.
What store do we want to use? SQLite?
Sure.
I was kind of thinking dirty, but you know.
Oh.
Whatever.
When the magician picks a volunteer, he usually knows who he's going to pick.
Person, name, string, age, and ID.
So we're making
Person equals ID extends document person. There's our basic. This gets mapped to the database. So I have a document and a document model, and for those of you not really familiar with Scala, the object is a companion object that maps to it. So it's basically a helper, and object is the alternative to static because there's no technically such thing as static in Scala.
Kotlin does the same thing with companion objects.
Yep.
No statics.
So I need to be able to support lazy val. I need to be able to support converting this person object to and from JSON. And so this uses my JSON library called Fabric. And I just, RW is how it needs an RW instance, which I can create one by hand if I want to, but I'm just using the macro gen, and it generates it for me at compile time. And then I don't need that because I'm going to use extends JSON.
So why are we making it into JSON?
Because that's how it gets stored in the database.
Okay, we're doing a document database thing, not a relational.
Yes.
Okay.
JSON something. Oh, with.
How many years have people called it JSON and you not turn your head?
All the time, especially if I'm on a conference call and not really paying attention. We start talking JSON.
JSON.
I used to call it JSON, but apparently it's JSON.
Well, I can't do it. Sorry.
Well, you know, the RFC says JWT is JOT too, but you don't have to do it.
Oh.
You can just be a rebel.
Yeah. Jot.
So this is all the mapping stuff. I can auto-generate if I want to, but all I have to do is do these two things, and then it'll do it for me. So, and we'll talk about it in just a second.
Yeah.
I'm just building the basic structure.
Your fingers are talking now.
Okay, so I'm gonna do database.init. Make sure that it creates the database. That'll create all the instances and map everything. And
And
then
it is
error if I've done something stupid.
And it is item potent, so the second time you run the program.
It automatically validates. Yeah. So I then want to say deep. Oh wait, I gotta actually.
This is schemaless, right?
Yeah.
I
well,
see
no,
a-
it's
I
not
see a schema.
schemaless. It's code-driven schema.
Yeah. Okay. Strongly typed was all over the slides. He was serious.
Well,
about
that's a good point.
it. Yeah.
So if you change the structure of person, it will update.
That's a good
database
question
for
about
you.
migrations.
Flyway.
Let's find out what the danger is about that.
All right. So now we have.
Flyway?
Oh, wait,
No,
I'm gonna call
Oh.
in LightDB.
people.
That's a big problem.
People. I'm going to create a transaction, which I need a transaction in order to work on anything. Action.
Okay.
And then I say database people.insert, and then I'm going to insert a list of person, John Doe,
Sounds like a land we're in.
30.
I mean, we've got all these nice people here that
I
can do it
don't
in the
like these
database.
people now.
Oh.
Yeah. Okay. So I got a transaction that inserts the people, and then I create another transaction. Because as soon as this completes, this will commit any changes
Okay.
that are made and everything, and make sure that it's all persisted and indexes are updated, and so I just guarantees that
Okay.
everything's properly set before
Yeah.
I move on to the next. Which, depending on which store I'm using, some don't support transactions, so that's a little bit.
Interesting question too.
So then I can say database.people dot, let's do a query, dot filter, and because it's type safe, I can say where age equals 29 dot toList. And so what should I end up with in this list?
Jane Doe.
Wow, you go to the head of the class. All right.
I'm already up here.
It wasn't a very long list,
Yeah.
so.
50-50 chance.
Jason has computational database in his
Well,
head.
you had more than 50-50 chance. I mean, there's like 37 lines of code here. So.
Well, that's true.
All right, so
That
let's
makes
run it
less
and
than
see how
50.
badly it breaks. Let's say run. Uh-oh, it did break. Okay, I didn't import something. Import, done. Run.
Oh,
Yay,
LightDB.
I probably need to
LightDB
learn
works.
Scala. Oh, okay, it automatically printed?
Yeah.
Well, so this is the print.
Oh, Scribe, yes.
Scribe, it's my login library.
Yours.
Yeah,
Okay.
Now, I have a syntax question.
Yes.
So db.people.transaction. Transaction, I guess, is a method.
You're on line 17.
So,
Function. 17,
So
24, take your pick.
db.people.transaction. So if I look at transaction, go to it, and then it actually is an object within. So this is actually kind of convoluted. But what's actually being called is this apply method.
Sure.
So in Scala you have syntactic sugar. So apply methods can be called without saying apply. So if you just pass like, so if I do
Something that
like,
has an apply method gets applied.
yeah. So if I say def apply
Yeah.
unit scribe info, and then I can say here example. Boom.
Yeah, just run an example.
That'll
And
call
apply-
it. I
apply
can
can
also
be
call
overloaded.
dot apply, but that's
Can apply be parameter matched?
unapply is what can be parameter matched.
Unapply?
Wait,
On.
are you talking about?
No, like if I
unmatched?
had apply with one, like overloads or.
Yeah, you can do overload.
So, okay.
Yeah.
So it's calling apply on the transaction object and passing, I guess that's a lambda.
Yes.
And implicit transaction, what's going on there?
Implicit.
So implicits are fun things. So if I comment out this line and this line, I then get a complaint saying there's no implicits found for the parameter transaction. So what I have here in transaction, the apply method, if you see here, so it takes a function that receives a transaction and returns return, whatever that generic type happens to be.
Okay.
So I could change this to be just transaction because
then
that's
pass
what I'm
it.
receiving,
Yeah.
but then it's going to complain. I can get rid of the implicits and just say transaction, pass it in. If I
That
want
looks
to.
more Java-like.
Yeah, that's more Java-like. That's why I'm using this, because I'm passing it this as an implicit,
That's a
and it
good
becomes implicitly available to anything that's requesting an implicit for that type.
Gotcha. Okay, thank you.
So even if the lambda took two parameters, one of which was a transaction, that would still.
Well, so if you look at if you look here, the implicits have their own
Okay,
curried function,
I see.
curried parameters. So I could have multiple implicit. So this is one of the things where Scala can get crazy, because I knew somebody, it was actually at healthcare.gov, the guy was insane, but he wrote this whole framework that you just call methods and everything that gets passed in was always implicit.
Oh gosh.
So it was so confusing to figure
Yeah,
out
to just
anything.
know.
It was like, why? I mean,
Why
it was
does that
just
do
like
anything?
he found out that implicits exist. It was like, oh, I'll just use it for everything. This is great. No. So I think implicits are great if they're used sparingly. There are, like in this case, insert most things. I mean, you can see in this code, most things require a transaction to operate upon.
Yeah.
And so
Go needs that.
by making it implicit, I define it implicit, and I don't have to explicitly pass it in every time. So that's a rational use of an implicit.
And you end up with a fairly readable. It
Yeah.
looks like a transaction.
Yeah, I mean this
Yeah.
is clean code, right, Jason?
Sure.
You know that book's getting a rewrite right now. It's in the middle of a revision.
And then, so let's go down here to line 25. This is where some of the cool things happen. So you can see here that .age is a type-checked value. So, and this is a function here, by the way. I can say p to make it a little bit less confusing. So what is p? P is a person.
It knows that, yeah.
It's a person type, and then I'm able to define my
And
parameters based
through
on
LightDB, that gets turned into whatever the underlying store calls that, like a
Right.
table or, you know.
basically a reference.
And from a language perspective, if you don't specify the name of the parameter, underscore is the
Yeah,
place.
underscore is a wildcard match to say, I only need this once, don't even give it a name, just use it.
Gotcha. Okay.
DB is not you though, correct? DB is a built-in Scala.
DB is this.
It's LightDB.
I created a companion object called
okay.
DB.
It is like DB. Yeah, okay.
So I could call this whatever I want.
Yeah, but my point though, or my question really was your lines 25, where you do a query.filter, so all the different kind of collection APIs you have written.
Right, that's
as
all part of
LightDB.
LightDB. And every implementation has to support that.
Yeah.
Which, that's the fun part. And it's actually really interesting because Derby was a pain in the neck, and I had to call my friend and tell him that it was such a pain in the neck to implement because I just did it for him. But all the
That's a good
other
friend.
SQL embedded databases are very loose when it comes to defining your types and things like that. It's like, I don't care. If you want to just give it a name and then whatever you send it to me, that's fine. I don't care. But Derby, everything has to be explicitly defined. You have to define it as a varchar, and you have to define the number on it, and all this mess. And it's like, I had to write so much extra code just to support that thing. But it works.
And then Scribe is
So
what,
Scribe is
more
a-
than a just console out?
Just a library, logging library.
Yeah.
It's my most boring project, but it's also my most successful project. 'Cause
Oh, I'm sorry. It's independent from LightDB.
yeah, it's used. So this is one of the features of Scribe is that you can use it without any imports.
Okay,
Because
broke my brain
this
on
is
that
the
one.
package,
Yeah.
and I can just call scribe.info. Done. And because one of the big pains about logging is you add all the logging imports, or
And
you
it's the bootstrap
you
stuff.
extend something or
Yeah.
whatever, and then you remove all the logging from it, and it's like, well, now you got all this stuff hanging around.
Yeah.
And this allows you to put stuff wherever you want it and never think about it again.
We just
But-
don't remove code.
But Scribe got brought in from your example project, not brought in from.
It actually got brought in
LightDB.
by LightDB because LightDB has dependencies on Scribe
Okay.
and on Fabric.
Okay.
Okay. So it's just a
Fabric is not
transitive
yours.
dependency that you're just using because
Yeah.
you know it's there.
Is Fabric yours too?
Yeah, I'm
Longer
a
story.
little bit crazy.
Longer story.
I'm a little bit crazy.
Did you write the
you-
IDE too?
No. But you
Interesting story.
Jason dipped his toe in something a minute ago. So what happens if you change the database schema after the database has been generated?
So you can break it.
Yeah, I bet.
But that's one. So one of the things that's here that I just sort of glazed over is this line here.
Oh,
I
okay.
have a full concept of database upgrades. So database upgrades, there's basically a key value. So if I look in my database here now, you can see there's a backing store .SQLite. So because we're just basing on SQLite, there's 2 SQLite files now for each database. And that's another interesting thing about this is I found that there's actually a wild performance increase by not having one SQLite instance. If I have a SQLite instance for each collection instead, use a little bit more memory, but it's way faster because SQLite is single-threaded.
Oh,
You cannot do multi-threaded with it, so it'll block. But if I have an instance per, then each one has its own
it
single
doesn't
thread.
have a single-threaded non-blocking access mode?
Well, I mean, it's synchronized, basically.
The whole database is, wow.
Yeah. So for single-threaded stuff, it's crazy fast, but if you do any concurrency, it starts getting slower. H2, on the other hand, this is one of the things about digging into all this. I've learned so many interesting things about it. But H2, on the other hand, is much better at multi-threading.
Hey, you do it's a crazy full table search. Everything else waits. That's
Well,
SQLite.
a search, no. Well, I'm not actually certain exactly because SQLite has some weird things.
Table scan is a lot of work.
Yeah.
Yeah.
Yeah. Wow. Okay.
They usually multi-thread insert, so when that code earlier, if another insert's triggered, it will
With SQLite,
Block out the other one.
it'll synchronize on the block, so only one thing can happen at a time. But you
Oh,
can't.
yeah,
So
block
I
is
actually have
blocking
I actually have a full async library part of LightDB, which I use for concurrency, because this is just the blocking core mechanism. Everything's blocked. Everything is sync, not async.
Mm-hmm.
So in a real production environment, I wouldn't be just doing this. I'd be doing like a Cat's effect and doing parallel processing and all
And
sorts
not
of stuff.
using SQLite.
And not SQLite probably. Although so one of the cool things here is that's interesting is I can say if I had another collection, let's say I create another other people, and I can create multiple collections with the same type, and I say collection person, and then I can say the store manager for this is let's say H2 store.
Where did you tell it? SQLite? No, I forgot.
So SQLite store is the default store
Okay, yeah,
manager
got it.
that's used by everything by default. But I
But
can
you can
override
talk-
that, so I can share. I can have multiple
Yeah.
different databases in use within the same database.
The same
Oh,
like
you overrode store manager. Got
Right.
it. Okay.
Because it'll default. So store manager, you can
It's
see.
an implicit.
It's not actually
Not
not
implicit.
implicit.
No, I'm talking
It's
lines.
default arguments.
Oh, okay.
Yeah, I'm talking line 37. You have
Yes.
already defined store
Yes.
manager
This
in
is the
LightDB,
Default store manager.
and DB is saying, "Hey, I want to use SQLite for that." Got it.
Right. But in the case of other people,
Yeah.
I want to use H2.
Yeah.
Any questions? Pretty code? Okay.
the database upgrades are part of the source code.
Yes.
They're not stored in
So
data
a database upgrade is a cool thing. I was showing you the backing store. Basically, the backing store is just a key value store that has string to object representation. So I have in the database, in the backing store collection, I have a upgrades key that has a list of the upgrades that have been applied. Basically, a list of strings that have been applied. And so at startup, it checks the ones that it has available versus what's been done already, and if it hasn't, it basically creates a
careful
list
state.
of things to run and then runs them. And then I have things like apply to new, so
Yeah.
that if it's
So you can break it. If I delete some of the database upgrades out of the code that are already in the backing store,
It
I
doesn't
have a
matter.
I don't have a conflict?
no,
Okay.
because it just says, oh well, I don't care if it's already been done.
Yeah.
I just care about what I have
Versus-
in my code that doesn't
Yeah.
exist in the
So
list.
the backing store needs to survive.
Yeah,
the-
backing store doesn't exist.
But the code does not need to remember everything.
Right.
Yeah. All right.
Yeah, you can eventually delete it if you know that it's
Yeah.
everywhere.
Mhm. That's pretty sweet.
And then you can have, so block startup, this is a cool feature. So you can have upgrades that,
Yeah.
so the upgrades take place in order,
There's a life cycle.
right? And then whenever it gets to a point in time where all of the remaining updates say that they don't block startup, the database will fully start, and it'll run the rest of them in the background. And then you can have always run that, so it doesn't matter if it's run before, it'll always run this upgrade. And then this is just the block of code that actually runs the upgrade. It's pretty simple.
Yeah. I can see what you mean by power. You don't mind if I shoot my foot off. You give me a way not to if I want not to, but
Well, and even if you do, you can still write an upgrade that happens at the beginning
Yeah.
of it to say,
Yeah.
I can go through and I can parse out the, so, and in fact, I ran into this recently because I had a code change that modified the schema. And so I basically just renamed a variable, which it was not an optional variable, so the code would break if I tried to restart the server. So I had to write an upgrade that basically loaded I streamed through that entire collection, loading them as JSON, modifying them, sending them back to the database in their modified state, and then the database started up and it was like, oh, everything's fine.
So you have to write Scala code that manually takes in the old
Updates your
objects,
schema.
changes to whatever the
Your
new one is,
DDL.
and sends it back.
which is so much better than writing by hand SQL queries in production. which is what most, like, what
Yeah.
50% of companies are doing.
I use Flyway,
Yeah.
which
Yeah,
works
Flyway
pretty
is
well.
pretty nice.
I like Flyway.
I've used Flyway.
This is random but slightly related, but have you heard of the library called Juke? Jooq?
I've used it.
If you like database internals and going down rabbit trails, his blog is fascinating.
That's interesting. I don't think I've ever looked at the blog, but I have used Juke. In fact, I tried to use Juke for the SQL implementation of this initially, but the performance wasn't as good as writing it by hand. So I've got some messy SQL store. Got some messy SQL stuff that's going on here. SQL Builder. Yeah, this thing. This is kind of nasty,
Yeah.
Mm.
but it's crazy fast.
Well, it's not 4,000 lines long, so.
Yeah, I mean, it's pretty short. That's 101 lines of code. But this is just what basically brings it all together, because these are all SQL parts, which a SQL part is SQL with their arguments.
All right, awesome.
Do we have any more time to talk about Reactify?
We technically have 5 more minutes.
Cool. Challenge accepted. Okay, so Reactify. I don't remember who it was that was asking last time. I was here about Reactify, but it's my FRP library.
That
Now
would've been me.
it's my. Oh, okay. So it's actually it's one of my coolest projects, honestly, but it's because nobody understands it that is so cool about it. So, you know, the basic concept of a reactive library is that you can do stuff like, where is it going? Got some code here. Okay, so I can set a var, and then I can attach listeners, basically. It's an observable pattern, basically.
Yeah.
But existing reactive libraries, I don't know of any, maybe there's another one that does this, I haven't looked at everything, but to my knowledge, this is the only library that does this. And again, I give credibility to Insanity for coming up with this idea. But, so the way that I accomplish this is by, I'm able to do things like, where's an example here? Right, here. So I create 3 vars, 10, yes, no, and then I can create a complex val that just uses an if-else condition within it. No magic, it's a standard if-else, conditional. And this evaluates as a function, and then upon evaluation of this function, I have every val or var that is retrieved as part of the processing of that function. Basically, I capture a reference to them so that I know which variables have been used, and then I attach listeners to them. And then upon any of them firing an event that they've changed, I reevaluate the function. And then if any of the variables have changed, like for example, in this case, when this is created, when complex is evaluated in the first place, v1 greater than 10. No, it's not. So the variables that are monitoring are v1, because I have to get that in order to determine it's greater or less than 10, and then v3, which is the return value. I'm not monitoring v2 because I don't care. So then, whenever v1 changes its value, it fires an event. It captures it, reevaluates, and now says, oh, well, now it's 11, so this conditional runs again, and so we can't care about v1 and we care about v2, but not v3. So I remove the listener from v3, I add a listener to v2, and now I'm capturing for the new changes. So it's a really simple concept that actually could be implemented in Java, but nobody else has
Your
done
favorite
it.
language is Scala.
Yeah, I mean, I did it in Scala.
So
because
basically, at runtime, then, when you try to use the value of complex, it's going to like that code right there.
we'll execute the function.
It's going to execute. So v1 is not greater than 10, so it's going to get the current value of v3, which is no.
Right.
But then if you were to change the value of v3 from no to
Right.
and then evaluate complex again, now it's going to say rather than no. Correct.
A little bit more than that. Complex, it doesn't get evaluated. It is itself of an observable. right?
Yeah, it's also observable.
Yeah.
But
So
basically
it would
you have this
generate a
chain.
new event, or be, yeah.
Yeah, and so you can listen to complex, you can listen to V3, you can listen
Mhm.
to V2, you can listen to V1, everything. And actually that's what complex does, is it's listening to these things to
Mhm.
waiting to see if they do something. I can have something else that's listening to complex.
Yeah.
And then you can do crazier things like this here, like active. I can have evaluation of a function, flat map on it, get the foo.
Mhm.
So if you can see that the foo and bar, they have vars within vars within vars, and it's kind of crazy, but determining the value of this Boolean that is a var called active within foo,
Yeah.
that's within foo as an option that's in var, that's in bar, I can then create this derived Boolean
Yeah.
that will always
works.
represent the proper value.
I'm a little confused that, I guess in Java, one of the many languages that does, one of the frameworks that does it is the standard Java reactive streams. They have two things. They have a mono and a flux.
Hmm.
One that can generate many events, one that can do 1 or 0.
Right.
You don't?
I don't.
You just
My-
have a flux.
Basically,
Yeah.
so I've got var and val are my primary things for
Mhm.
standard. I mean, I've got channels, I've got
Mhm.
depths, I've got all sorts of other things, but val and var. Val is, it can't be modified itself. The things it's listening to may
Mm-hmm.
represent changes, but it can never be set itself.
Yeah.
What it's defined as is what it is.
Yeah.
Var, on the other hand, is a variable. You can change it. It's
Yeah.
mutable.
Yeah.
All right.
So you don't have something that can emit many events, like a click stream or something.
Well, channel is basically a var that doesn't maintain state.
Okay. Yeah. There it is.
Yeah.
I don't know if that was
Channels.
5 minutes. Sorry, Jason.
We're right at.
Sorry, Jason.
Boom.
Right at 5 minutes.
Yeah.
You can call me B.
What
Jason
are we
B.
waiting?
Yeah.
That was terrible.
That was on camera too, man. You've been recorded.
My face wasn't, but
Yeah, that's true. They'll never know. They'll never know who it
they'll
was.
never know. But moment.
Whose
I'm my
name was
twin
Jason
brother.
B.
Yeah.
Yeah,
All right. Any other questions, comments?
Thank you, sir.
Anything you'd like to say in closing?
Yeah.
No.
If anybody's interested in Scala, I'd be happy to talk to you about Scala in the future. And I've got a lot of really other cool libraries. I've actually been, if anybody's interested in, if you've been looking at virtual threads, I actually just recently wrote a prototype library just to play around with performance of virtual threads. In fact, I can show you real quick. Rapid. Click. Okay, I broke it. Never mind. I can't show you the benchmark. Oh wait, well, yeah, I can't show you the benchmark.
Live demos.
Yeah, I accidentally deleted it.
For people like the people in this room who've all learned multiple programming languages, if I were to try to tackle Scala for Advent of Code this year, I would kind of want the right selection out of all of the learning materials. So for experienced programmers, what's that?
So if you want to learn Scala, I would say the Programming in Scala book is incredible. And it's funny, I bought the first edition of the book whenever it came out, and I sat down and I read it like
Cover to
it was
cover.
a novel.
Yeah. I did Ruby like
And
that.
realized that, okay, crap, I didn't do any of the examples on the machine, so I remembered none of it.
No.
And I had to read through it a second time to actually learn it. But it's actually a really fun book, I think. And it's written by Martin Odersky, who is the actual creator of Scala, and two other guys, like Spoon and Bill somebody. Anyway, so that's a really good book. That's what I'd probably recommend.
Language to language, I find that the book approach works better or worse. Like Elixir, the book approach did not work. The online tutorial approach worked. but Ruby was very much the pickaxe, the book. So I was always asking you. You did the book twice. I don't want to have to do it twice.
Heed my mistakes and do it and read it in front of a computer so you can enter the code and learn from it.
I was actually reading.
Have you tried to use AI tools for Scala and see what kind of code?
Yes,
I was curious how
I've really
to
thought about
train.
creating a blog just with the hilarious results.
That's I'm
coming
curious
from, like-
about it.
But I
yeah.
think that's true about any language.
Let's see,
AI
most of
is-
the training is like for Java and C#. Probably.
AI is
I'm curious about
super
how much
dumb,
training has been
but
done for Scala.
even if you're doing C and C#, I mean, so for example, Apache Lucene, you probably all heard of, if not used it.
Yeah.
If you use Solr, if you've used Elasticsearch, if you most anything for searching has used Lucene. Now, Lucene's been around forever. If you ask a question of ChatGPT specifically about Lucene, it will often give you a answer from like version 3 of Lucene, which is on like version 9 now, and completely different.
And not,
And then you
Tells you
say,
that, not
I'm
disclose
using Lucene 9,
And it doesn't.
this method does not exist anymore. And it says, you're right. And then proceeds to give me more false code. And I'm like, that also does not exist. You're right. And then gives me more false code. Because part of the problem with AI is it doesn't seem to comprehend.
and they're doing
Time.
some kind of pre-prompt that makes it always tell you you're right. Like real text on the
Yeah.
internet mostly says you're wrong. You would think the AI would mostly say you're wrong.
That is a great idea for a project. An AI that mostly just says, you're an idiot.
That's what the real internet says.
Pretty much. All right, so if we have no more questions, we'll go ahead and close out. Thank
We're
you,
gonna
Matt.
close the stream.